Hello everyone, I came back with another video about my experience working with Motor-Wizard from EMWORKS Studio software. In the previous video, I described some options of this software that we can create a motor with just giving the software the numbers of poles, the outer diameter and inner diameter, and some geometric parameters of the rotor and stator. And with defining the winding, we can create some analysis like no load analysis, back EMF, performance analysis that shows the efficiency map, and unload and inductance and DQ inductances of the machine. In one of the analysis, like unload, the eccentricity option got my attention, and in this video I will focus on this option. Now let's talk about this ability that the software inputted in default analysis. We can choose dynamic, static, and mixed eccentricity and no to simulate the motor without any eccentricity. This option exists in other software like Ansys Maxwell, and I have video about how to perform the eccentricity fault in motors with Ansys Maxwell. But you have to do the changes manually, or there is option here in view. If you add the ACT extensions, you can find the Maxwell eccentricity here. If you click on Maxwell eccentricity, you will find options to do the dynamic or static eccentricity using the translation vectors. If you define the rotating part eccentricity, you will model the dynamic eccentricity, and if you change the place of rotation axis, you will model the static eccentricity here. Whether if you model the eccentricity manually or using this extension, you can get the results for different types of eccentricities. In the extension, you just need to define the translation vector and click on finish. It will create another design with the applied eccentricity. If you move on to the variables, you can see there are two variables here that defined for eccentricity, and they change the location of each part of the rotor or change the center of the rotation of the band. But the point that attracted my attention in the simulation using Motor-Wizard is, first of all, it is the default option. You can easily select the type of eccentricity and define the percentage of air gap eccentricity. But let's have a closer look to the dynamic eccentricity. The point that was important for me is we can define the dynamic eccentricity speed. It's a new option for me. In Maxwell, when you create the dynamic eccentricity, it will rotate with the same speed that you defined for rotation. Of course, in this way, you cannot change the speed of the dynamic eccentricity any other number than the rotation speed. The rotor displacement will have the exact speed as the rotor rotation. But here in the Motor-Wizard from the EMWORKS, we can change the dynamic eccentricity rotation speed. In the design, we can see the rated speed or maximum speed was 7,500 RPMs. But here in the eccentricity setting, we can change the number as the same speed as the rotor rotates, or make it lower speed or even higher speed. I couldn't do that in the Ansys Maxwell, so I wanted to understand where should we define different speed for the dynamic eccentricity than the rotor speed. We know that the eccentricity fault usually happens with the failure of the bearings. So please participate in the discussion below that how can we utilize this option in simulation? Do different speeds will affect the results? Different speeds of eccentricity with the same speed of the rotation. How they will affect the results and what scenarios in the real world will happen. Does the dynamic eccentricity have higher speed than the rotation of the rotor, or it is usually rotating with the lower speed? Which one and which scenario is more realistic? If you have any experience on industrial applications with the eccentricity, please share with us. It will improve the knowledge of all the colleagues. Thank you very much for watching this video. In the next video, I will describe the result of different speed simulation, and I will try to simulate the design motor with the standard part 2. If we use the motor wizard to design a motor, we can easily create a 3D model from the design to simulate it fully finite element analysis with the standard part of the EMWORKS Studio. If you like the video, please hit the like button and remember to tell us your opinion about different speeds of dynamic eccentricity in the comments section. Thank you all and have a good time.